Holly Jones is a healthy young woman.
Hi, Mayfield Stanley, 6th floor.
But her body is about to become a battlefield. A sneeze explodes into the air at 40 miles an hour, the equivalent of a force 8 gale, sweeping 100,000 droplets of mucus into every corner of the lift.
Excuse me. Bless you.
Most of these droplets are harmless, but some carry living organisms which are highly infectious. These bacteria and tiny viruses were spawned inside a human body. The cold, dry air of the lift will kill them in minutes. They urgently need to find another human host. The invaders have found refuge in Holly's nose, but they're not safe yet. First, they must get through the forest of hair which lines her nostril. These hairs are her first line of defense. They trap nearly every particle she breathes in. The invaders are swamped by a wave of mucus. For the bacteria, this is as far as they will get. An enzyme in the mucus dissolves them away. But just one spiky virus survives. The spikes on the virus allow it to impersonate one of these proteins. It docks with receptors on the surface of Holly's cell. The cell is fooled. It reads the virus as a harmless protein. The virus slips inside. Holly's cell has become a virus cloning factory. From this single throat cell, 10,000 viruses are born. The frontline troops of the immune system are the natural killer cells. They patrol Holly's body, looking for trouble. They spray a poison to destroy the pieces of virus being hatched inside the cell. But this is warfare of the crudest kind. In the process, many of Holly's own throat cells are obliterated. Trying to contain the virus, her own immune system has destroyed thousands of throat cells. Holly's throat has become raw, swollen and sore. The next phase in Holly's immune response has begun. Now her whole body will be recruited into the battle against the virus, and her well-being will be sacrificed until the war is won. The macrophages working in her throat release chemical smoke signals called interleukins. Interleukins surge through her bloodstream, summoning reinforcements to the battlefield. The interleukins have opened up a new front against the virus. Holly's brain contains a natural thermostat, which keeps her body temperature at a steady 37 degrees. Unfortunately, this temperature provides a perfect breeding ground for influenza B. So the interleukins turn her thermostat up. This tricks her body into thinking it's cold. She shivers to heat herself up. Holly is getting a fever. As her temperature rises, virus cloning slows down, but other processes in her body speed up. New immune cells are produced at a faster rate. Even her hair and nails grow 20% quicker than normal. Though very high fevers can be dangerous, it's no bad thing that she can't find any pills for her headache. Painkillers would also lower her fever and give the virus a new lease of life. More and more killer cells have arrived in her throat, but millions of new viruses are still being spawned. The immune system is one of the most remarkable features of the human body. Here in Holly's lymph, 1 trillion cells known as T cells and B cells are floating. Each one individually designed to kill a different foreign invader. Each one waiting for the call. And among these trillion cells, just one T cell and one B cell are designed to deal with influenza B. If they're found, they'll mount a devastating pincer attack on the virus. The dendritic cell reaches one of Holly's lymph glands. It offers up its virus spikes, seeking out the one cell which might recognize the virus. Finally, it docks with a T cell. For 25 years, this one T cell has been waiting to be called into action. It begins to divide. Within hours, the original cell will become thousands of T cell clones. Packed with dividing T cells, Holly's glands have begun to swell. But this time her pain is a sign that the tide is turning. The T cells are launched into her bloodstream. They home in on infected cells and take them out with surgical precision. The final battle has begun. In Holly's lymph, a B cell has recognized a virus spike and begun to clone itself. Unlike T cells, B cells don't go to the battlefield. Instead, they manufacture millions of minute proteins called antibodies. Like tiny heat-seeking missiles, the antibodies target newborn viruses, locking onto their spikes. Smothered in antibodies, the viruses are paralyzed. They can no longer infect Holly's cells. Most of the T cells, their job done, shrivel and die. But some, known as memory cells, will patrol her body forever. The memory cells make Holly immune. If the virus tries to invade again, they'll instantly wipe it out. But influenza B has one more trick to play. It can mutate, so that next time Holly's memory cells might not recognize it, and she'll get ill all over again. Though Holly no longer has flu, the last few viruses remain in her saliva. A virus can't survive outside a human host. It urgently needs a new body to colonize.